Alright, welcome to Unit 5, Day 3, and you'll notice that I've pulled this paper back out. This is the paper we went over on Day 1 over our properties of parallelograms, rhombi and rectangles, and squares. And so today we're going to take a look at trapezoids over on this other side. So we're going to take a look at trapezoids and then specifically isosceles trapezoids. So we're going to jump right into how to start filling these in. A trapezoid, first of all, is not a parallelogram because it has only one pair of opposite parallel sides. Okay, there's only one pair of opposite sides that are parallel. But since we do have that one pair of opposite sides that are parallel, we do get that consecutive angles are supplementary along those parallel sides, okay? So these consecutive angles are supplementary, and these are, not all four, okay? We don't go along the parallel lines, we go across from each other. So we have consecutive angles are supplementary on either side of that. Now, the sides that we know to be parallel are called bases. So these are base angles here and here, and base angles here and here. So these two base angles are supplementary, and these two are supplementary. And it just works the same as our consecutive interior angles theorem from Unit 3. And then we have what is called the mid-segment of a trapezoid, which is the segment that connects the midpoints of the non-parallel sides. The non-parallel sides we call legs. Okay, and because it connects the midpoint of each side, it gives us a relationship that it is parallel to both of the bases, and it is the average length of the bases. All right, so the mid-segment is the average of the bases, and it's parallel to both bases. So the two parallel sides of a trapezoid are called bases. The non-parallel sides are called legs. Now, if we have a trapezoid where the legs are congruent, we call that an isosceles trapezoid. So once again, the non-parallel sides, or legs, are congruent. And in this relationship, these diagonals are also congruent. All right? The base angles along each base are congruent. So these up at the top base will also be congruent. And then opposite angles end up being supplementary as well. Because the consecutive angles are supplementary and these base angles are congruent, opposite angles are supplementary also. So there's a lot of different things we can do with trapezoids, a lot of problems we can solve with these basic facts. Okay. We're going to do some extra examples, so I'd like for you to get out your own piece of notebook paper, and you can title it this way if you want, Unit 5, Day 3, Examples. And then I've kind of drawn some of these out for you, so you'll need to pause the recording long enough to make sure that you have these copied down. Okay, we're just going to do them one at a time. If you want to kind of copy it down and then continue to push play, we can work one out at a time. I'm not going to show you them all at once. But again, if I'm going too fast at all, to stay caught up, just pause the video. All right, here's what we're going to do in example 1. All right, we are given a trapezoid because MN is parallel to PO, but the other sides are not parallel. And we give you angle M and angle O, and they want these other two angle measures. I want you to remember that the angles that would be considered consecutive interior angles, so these consecutive angles on this side are supplementary. Okay, those are supplementary. And these angles are supplementary. So to find angle N, we just take 180 minus 45, and we get 135 degrees. And to find angle P, we take 180 minus 121, and we get 59 degrees. Okay? All right, take some time to copy down example 2. We have trapezoid ABCD where the bases are AD and BC. Those are the parallel sides, so those are the bases. But these legs that are not bases, AB and DC, are marked as congruent. That means this is an isosceles trapezoid. Which means these base angles, B and C, are congruent. So those will be the same value. And A and D are congruent. So I automatically know that D is 118 degrees. So I can just write that in. Now to find the other angles, B and C, remember that consecutive angles along a leg are supplementary. So the measures of angles B and C come from taking 180 minus 118, which equals 62. So both B and C are 62 degrees. Okay, that leads us to example 3. Go ahead and pause the video to give yourself time to copy this down. All right, I'm going to zoom in a little bit. Maybe that makes it a little bit easier to see. Here we are given a trapezoid. I know it's a trapezoid because ST is parallel to VU. But I have marked SW and WV congruent. That means W is the midpoint. And TX and XU are congruent. So X is the midpoint of this leg. Since I'm connecting the midpoints of the legs, that makes WX a mid-segment. Okay? And in a mid-segment, it's parallel to these, and it is the average length of these two bases. So to find the length of WX, we're going to take the length of ST plus the length of VU and divide by 2. So ST is 6, VU is 10. We're going to add those together and get 16. 16 divided by 2 is 8. The average of the two bases is 8, so the length of the midsegment is 8. All right, and that leads us to example 4, a very similar problem. Again, pause the video to copy this down if you need to. We are given another trapezoid, ABCD, and again we're marking H as the midpoint of AD with the congruent parts here, and L is the midpoint of BC with the congruent parts here and here. So that makes HL a midsegment again. And so I want you to find the length of CD. And in order to do that, we have to use what we know about the midsegment of a trapezoid. The midsegment of a trapezoid is the average length, but since I've got these expressions, I've got to write it out as an equation. So I want you to write it this way first. the length of HL has to equal AB plus DC, or CD, all over 2. If I add the two bases, these are the bases, and divide by 2, that's how I get my mid-segment length. And so I'm going to now substitute the parts for these different segments. So instead of HL, I'm going to write the expression 3x minus 12. Instead of AB, I'm going to write 18. Instead of CD, I'm going to write 4x minus 2. And I have to divide all that by 2. And then I just start to simplify my equation. On this side, I still have 3x minus 12. On this side, I can combine 18 and negative 2 and get 4x minus 16 on the top. And there's a couple ways we can go about this. Since I noticed that 4x and negative 16 are both even numbers, I like to distribute the division of 2 and get an equation without a fraction. 4x divided by 2 is 2x. Negative 16 divided by 2 is negative 8. And so now I can start to get x by itself, subtract 2x from both sides. Running out of room. 3x minus 2x is just x. So I'm going to add 12 to both sides. Negative 8 plus 12 is 4. So I get that x is 4. I'm sorry, I noticed a mistake. Let me go back all the way and fix it. 18 plus negative 2 should be positive 16. So when I divide that by 2, I should get positive 8. When I add 12 to positive 8, I don't get 4. I get 20. And I'm sorry if that confused you. I didn't mean to. You probably caught it before I did anyway. So x is 20. And now all I have to do is plug back in to find CD. Instead of x down here, I can write 20. So 4 times 20 is 80. 80 minus 2 is 78. Do not put a degree symbol. These are segment lengths we just found. All right, so these examples give you a little bit of an idea about what the problems will be like on the assignment that we work on for Unit 5, Day 3.